Exercise 40. So let's talk about this least square problem. So let's work with precise problem. So what is least square problem? Least square problem is when you have linear system Ax equals b. Let's say x b Rn, or x as unknown. Let's say b Rn, a center. As a convention, usually we say A is n by n matrix, and then it gives matrix transformation from Rn to Rn. If it has a solution, we'll call this linear system consistent, and you just solve it. This is very typical in linear algebra, but notice that if B is not in the column space of A, which by definition is the span of all the column vectors of A, where, let me write A, let's say, has its columns to this form, then Ax equals b does not have solution. Because what is Ax? Ax is just linear combination of columns of A. Let's say if x is x1, xn, by matrix multiplication, this is just x1, a1 plus x2, a2 plus xn, a. And so x equals b has a solution, means b is a linear combination of the AI, which means b is in the column space of A. If it's not in the column space of A, then this does not have a solution. So in this case, we talk about the best approximation for a solution. So x hat is called least square solution if this Ax hat, although x does not equals b, but its difference with b, and you take the norm, which means in our case the dot product is less equal than all the other possible choice. Okay, so geometrically, what does this mean? You have your column space of A. This is the span of some column vectors of A. Let's just take an easy example. Let's say this is A1, this is A2. Suppose this is not necessarily dimension 2, but for the limited fact that we can only draw up to R3 on paper. So let's just take this. I mean, it doesn't matter. Just noted that this is the span, and I just to make it more precise to write that it could be something, and we just draw a plan for that. And then whatever Ax corresponds to some vector on this plane, right? And so if your vector b, for given b is in the plane, then this is a linear combination, and you have a solution. But if it is not, let me draw this. If this is your B, and it's not in this vector space, and then we talk about its projection, right? This is vector B, this is its projection. We call this projection B hat. And then notice that the choice of X hat such that it has minimum distance with B, this would be equivalent to X hat equals B hat, where this B hat is the projection of B onto this column space of A. And so finally, find least square solution is the same as solving AX hat equals B hat. But how do you solve that? How do you solve that only knowing B and A? So idea is, what happens if I just put the formula of B hat there? That would be possible. What if just put AX hat equals projection of B, column space of A? That would be possible, but it took a lot of work, right? Because the column space of A, if it has normal basis, also normal basis, then that would be good. This would be just B dot product A1, and then A1 plus B dot product AN, and then AN, right? Under this option, A1, A2, AN, also normal. But this is not the case in general, right? So it could be kind of difficult to compute this. But then we notice this is also equivalent to saying that B minus AX is orthogonal to all the AI, right? This is equivalent to say, let me change position, let me put this AI on the left hand side, because dot product is commutative, it doesn't matter where you this is equivalent to so let me say A1, A2, AN, equals 0. So this is a 0 vector in Rn. So notice what is the size of this. This is just n by 1, right? Sorry, n by 1. And so this is n by 1, and so transpose 1 by n. Finally, this is 1 by 1. And when I do this, this will become n by m, n by 1. And so this is n by 1 column vector. This is equivalent to the transpose of A times this equals 0. This is equivalent to AX hat equals AT B. And this is how we solve this square problem. X hat is the solution of this. I call this normal equation for the started question x equals b, which does not have a solution. Okay, this is still the remark. So let me put the question, which is example or application of this. Find best solution or say best approximation for Ax equals b, where A, let's say very precisely, -1, 2, -1, 4, -3, and 3. This b equals 12, 6, 6. Solution. So find x hat is equivalent to find solution for this. Normal equation, which in our case would be transpose of A times matrix multiplication with A, and then x hat, because x will be 2 by 1 equals again this matrix multiplication. So the left hand side, right hand side, you could compute what it is, simplify it into a non-homogeneous linear system. Just do the computation, we will see that this is the case. And then just solve this linear system. You will see it has a unique solution, which is 12, 6.